So this is one thing that we have to kind of understand. The second thing is all of us are born to perceive the world around us. Okay, we are all born to recognize. I mean, we are all born with the ability to recognize objects, orient attention, and avoid loss. So that's our basic what we call as animal instinct. And so here I've kind of summarized what system 1 and system 2 properties are. So uh, using system 1, we learn to associate ideas. All our learning happens through efforts that is put in system 2, but then it kind of gets added to the system 1 process where it becomes fast, automatic, and helps the everyday decision making. For example, if I were to ask you what is the capital of India, you don't have to really do any major exercise. You've already learned and it is already stored. So without even thinking, the answer automatically comes as Delhi. So similarly, we like driving. Once you learn driving and once you have kind of picked up a level of expertise, then it becomes automatic. Only thing is, while driving, if you have to kind of recall a particular number and a particular phone number of somebody and then tell it to someone, then you might have to share some of your, I mean, you will find a little bit of strain. Or if you have to do some calculation, mental calculation while driving, and if you at the same time want to overtake a long truck, it might, you will actually feel the mental strain there, okay? So, so what I wanted to kind of explain here is that system 1 is shaped by the evolutionary process, and it kind of runs a continuous evaluation or assessment of what are the main threats and opportunities and how we have to respond to that to stay alive, because we don't have the luxury of recalling system 2 to respond to such situations. And hence, most of the time that we spend when we are awake will be spent using system 1. Okay. The other thing is the ability to kind of what you call orient your attention or recognize danger is something that is not yet turned off in our brain. Like this is something that you can very quickly realize if you consciously look at how we react or respond to strangers. The moment you start interacting with a stranger, you try to what you call unknowingly or involuntarily try to make an assessment of how dominant he is, whether he's trustworthy, is he friendly or hostile, etc. So these are all things that run in the background as a background process without our consciousness, and our response to that particular stranger also would automatically be aligned to these particular thoughts. Okay, and this is one reason why we say that the first impression matters and first impression is important, etc. Okay. Now, the other thing is system 1 is error prone. Okay, so as we have seen in our bat and ball question, plus the gorilla, the invisible gorilla test, system 1 is error prone because it is fast and it is more involuntary automatic reaction. So that's another thing that we have to be aware of. Okay. So system 2, like what I already said, is slow, it is conscious, it is effortful, and it is something that we recall consciously to solve complex decisions, and thereby it is more reliable. Okay. Now let's look at a few quick examples and see as to how our mind works. And at least for the next few examples, I'll need some answers from you. Again, these are kind of simple questions which you can quickly respond to. So here is a statement. You can see this, right? Alex is a meek and tidy soul. He has a need for order and structure, and he has a passion for detail. Is Alex more likely to be a librarian or a farmer? Answers.
Librarian.
Anyone else?
Librarian. A librarian.
Librarians.
Okay, good. So yeah, I mean, he's meek and tidy. I mean, he has an attention for detail. So we have a mental model which says that Alex should be a librarian. But if you really look at our country, are there more male librarians or male farmers? So there's a fundamental principle of probability, right? Where there's something called base rate. I'm sure as engineering students, you would have learned probability and you would also be remembering a bit of it. So there's something called base rate. And if you really look at the ratio of a male librarian to a male farmer, it would be at least 1:1,000, right? And from that perspective, isn't Alex more likely to be a farmer? Because see, we don't have any other detail. We only have that particular statement that he's meek and tidy and all that. There's nothing else. And the only other information that we have is the base rate information, which is probably the ratio of farmers to, especially male farmers to male librarians. Right? So I hope you got the point that I'm trying to make here. Right? So what happens here is your associative memory kicks in, wherein you normally associate somebody with this kind of a description to be a librarian, and you tend to neglect the ambiguities associated with it, wherein, or you don't even ask for clarification. So that's what typically happens. Okay, now, what is the answer to this question? 1 into 2 into 3 into 4. Yeah, again, you don't have to do a multiplication, but like, can you give a number?
8 factorial.
Yeah, I mean, give me a number, no?
That's an engineering answer. Good.
Yeah.
But I don't think that is what Manoj is looking for.
But what number jump? What would be like? Is it say closer to 1,000 or closer to a lakh? I mean, what jumps to your mind?
Closer to 40,000 around.
Okay, so somebody actually did the calculation. Anyway,
Yeah, these guys are very fast with your calculators, Manoj. So you spend so much of time.
okay, so
typing.
yeah. So the other thing is, so typically, like switching off our engineering mind and the calculator mind. If I were to present this particular problem to somebody who knows mathematics and even to engineers, they would arrive at a number which is kind of low, okay, lower than the answer, significantly lower than the answer. And when I show it in this way, they would orient their answer towards a significantly higher number. That is what typically would happen. But I mean, all of us know that the answer is same to both the questions. But then, depending on how the question is posed, the answer typically varies. And like what somebody said, the answer is around 40,320 or something. But yeah. So you can see two lines with fins at the end. So which line is longer?
Same.
Same length.
Okay. But yeah, I mean, I agree to same length, but doesn't the one below appear to be shorter?
Yes, sir. It appears
Perception.
Yeah. So if you were to apply a grid or something and then check the length, the one on top appears longer and the one below appears shorter. And this is the typical optical illusion question that we come across. And even after measuring the length of the line and ascertaining that they are of the same length, we still see it as having, I mean, the one on top to be longer than the one on bottom. Okay. So, and this is what is an optical illusion. Now, like we have optical illusions, we have something called cognitive illusions. And cognitive illusions are what causes errors in our system one thinking. Okay, so that's what I wanted to kind of come to. And like what we saw in our a few slides back, system one is the real hero of our life, which kind of enables us to kind of quickly make decisions and move on. Because we generally would be taking at least tens of thousands of quick or involuntary decisions. Every action needs a decision. And because every action of yours needs a decision. There will be tens of thousands of decisions that you make every day, and you cannot actually invoke system 2 for that. So because system 2 consumes energy. Okay, so that way system 1 is extremely important, and that's what your life depends on. But system 1 is error prone. Okay, and like you saw optical illusion here, your system 1 thinking is prone to cognitive illusions. So we also just saw how associative memory works with the example of Alex and the librarian. So similarly, like normally we associate our eye with being observed, right? So that's what we typically associate pair of eyes with. Okay, so this is just a summary of what I just said, that system 1 works in the state of cognitive ease and system 2 in cognitive strain, and why it is important to understand more about system 1 and manage system 1 thinking. Okay, now let's look at a little bit more on the associative memory part. Okay, so so there was an experiment which was conducted in a university somewhere abroad, wherein so there they have, I mean, I don't know whether it is the same in your university as well. So here they have their coffee machines in various locations, and there are also some small snacks kept there. So typically people can serve themselves. It's a self-service system where you serve yourselves to a coffee or a snack, and then there's an honesty box placed there where you deposit the money based on the price list that is displayed there. So so this is a normal process that is there. So what was done is somebody pasted the picture of a pair of eye or a banner with a pair of eye just behind the counter where there is a coffee machine and the honesty box and the snacks kept. Okay, and they kept it there for 1 week. Then they didn't tell anyone about it. Then they replaced it with a pair of or a bunch of flowers the coming week, and they kept alternating this between week 1 to week 2 to until week 10. Okay, and what they did is they kind of graphed or made a graph of the picture of eye versus the collection. Okay, so I hope you can see my slide. So there was a very clear correlation between the pair of eyes and the amount of collection. So when people were asked whether they had noticed the banner of pair of eyes, most of them hadn't even noticed that the picture is changing behind that particular counter. But somewhere that associative memory subconsciously had worked, which made people more honest, because quickly we associate pair of eye with being watched, and when we are being watched, we would like to be more honest, right? So so this is one example of associative memory. Okay, now in this particular slide you can see two words, right? Madhu, I mean, you guys are with me?
Yeah, absolutely, Manoj. Yeah.
Yeah, okay. So you can see two words, and obviously because it is in a language that you have learned and you know, you cannot avoid reading it. So automatically you read banana and vomit. So that's one automatic reaction. The second automatic reaction also is that you associate banana with vomit, even though nobody told you to do that, nor you were asked to do that. But then somewhere that association comes in, and at least a few of you would recall some unpleasant experience, which kind of makes you feel a little uneasy. Okay, so these are all involuntary or automatic reactions that happen by associating things which are otherwise unconnected, and this is how system 1 works. Now, what do you read here? What do you see here?
ABC.
ABC.
And what do you read here?
I3C.
13C.
1214C. What do you see here? 12, 13, 14, is it? Right?
13, 14.
Yeah.
Yeah. So what is there in between? These two are the same. Okay. But again, like just like what I already said, when you say A, you would read it as B and then C, because the preceding and the succeeding one is an alphabet. You wouldn't read it as A13C or 12B14. Generally, even though you have not been told, your mind again jumps to a conclusion and then doesn't clarify normally. So this is how normally our mind works. So what I wanted to kind of explain through these examples is that system one works automatically. It doesn't clarify, it doesn't wait for clarity, or it doesn't wait to clarify ambiguities. And hence, in cases like this, it's okay. But then in a lot of cases like the bat and ball case and things like that, it tends to make errors which can be costly. Okay. And these are generally caused because of what we call as cognitive biases. Okay.